when they mention relative extrema, remember extrema is just a name for a relative max or a relative min. Remember when we made our x, y prime charts and we had to check to see if that first derivative changed from plus to minus or minus to plus, that made it a relative min. As you refer to your blue packets, right here, what we're looking for, f is going to have a relative max if your f prime changes from positive to negative. That means your function changed from going up to going down, from increasing to decreasing. So you would have a relative max right there. And f would have a relative min if your f prime changes from negative to positive. That means your function went from decreasing to increasing and then creating a relative min right there. So for part A, it says determine whether f has a relative max or relative min. So what I have down here for us is the justification for letter A. I kind of talked myself into getting the right answer here. I just kind of mentioned like f has a relative extrema, meaning a relative max or min, wherever that first derivative is equal to 0 or undefined and changes sign. That's the big thing. The derivative must change sign to be an extrema. And then once we figure those out, you can kind of classify them as max and min. So you're looking for where f prime changes sign, and see how it goes from positive, stays positive, then it goes to negative. So x equals 2 is going to be something, and then it stays negative on each side of this. So you're looking at that f prime row. Where does the f prime change sign? And the only spot where that f prime changes sign is at x equals 2. Now, this is your y row. This is like your y prime, y double prime row right here. So your f prime changes from positive to negative. If we did our arrows from before, that means your function went from increasing to decreasing. So at x equals 2, that would be a relative max. So I wrote down relative max at x equals 2 since the f prime changes from positive to negative. So you need to have that phrase in there. Don't use the pronouns. Don't use it changes. They're not going to know what you're talking about because you got 3 different things up on that chart there. So you got stress that f prime changes from positive to negative. Now notice that x equals 1, your derivative is equal to 0 there, but the derivative stays positive on each side. So that means the function is just going to keep going up. At that point, it's not going to be a max or not going to be a min. So there's part A. Now in part B, you're supposed to sketch the graph of f. So here's what I'm doing. We had a few different intervals at the top of this table here, okay? So we're in between 0 and 1, 1 and 2, 2 and 3, 3 and 4, and I just kind of jotted those down to the side. And then you're gonna do these like we did in chapter 3, and you're gonna look at the sign of the first derivative and the second derivative. So if we look at in between 0 and 1, see how my first derivative is positive? That means that we're increasing. If my second derivative is negative, that means the graph is concave down. So that's what I'm looking for. So I'm looking at that, I'm seeing increasing concave down. So in between 0 and 1, I drew something that was increasing and concave down. It also gives us points right here. Like this is the point 0, -1, 1, 0, 2, 2, 3, 0. Like those points are on our actual graph there. So I plotted those points first. And then in between 0 and 1, we're increasing concave down. So I made it going up and spilling the water. And in between 1 and 2, our derivative is positive, so we're increasing. Our second derivative is also positive, so we're concave up. So that's why I jot down for myself, increasing concave up. Now, you don't have to jot all that down. If you go look at that chart and do that stuff in your head, great. I just want to make sure we're being thorough here and we understand where everything is coming from. So that's why in between the 1 and x equals 1 and x equals 2, I drew something going uphill and holding the water. In between 2 and 3, same thing, negative and negative. So we're decreasing concave down. So I drew a decreasing concave down. And then the last part, we're decreasing concave up. So I made a decreasing and concave up right there. Now at x equals 2, we should have a max. Part A, we said x equals 2 is a max. We also have that the derivative changes from positive to negative to make it a max. But notice it also says the derivative is undefined. So since the derivative is undefined, but you actually have a y value there, it means it's not an asymptote or a hole in the graph. So that means it comes to a point. So if your derivative is undefined and you still have a point there, that means it's going to come to a point. So that would be not differentiable. That means your derivative is undefined right there. So that's why I kind of jotted down a couple things to the side that it should come to a point. Now, if that derivative was equal to like 0 or something there, then it would have been like smooth and curvy, and then the concavity would have had to change and all that good stuff there, okay? But there's that. Letter C, I believe, is the first time we're seeing something like this, okay? So ignore everything else right now. what I need you to see here, when you have G as the integral of F, this little thing here is I always jot down for myself right when I see that. And so if G is the integral of F, they'll always use different letters right here. So don't even worry about why they got X's and T's. They don't have to be the same variable there because it's just representative of a number later on. But so they'll always use different letters there. But if G is the integral of F, then that means when you take the derivative, the G prime is just going to be that. When you do the derivative of the integral, you're going to get the inside function. So that's why G prime is equal to F. And then you take the derivative of both sides again. Derivative G is G, derivative G prime is G double prime. The derivative of F is F prime. So I always jot that down. So G is the integral of F. G prime is equal to F, and then G double prime is equal to F prime, because we don't have anything in that table above any information about the G. So that everything is in terms of F. So we have to turn it in terms of F right there. Now letter D on this is actually going to be easier than letter C. But let's just go through one thing at a time here, okay? It's talking about extrema. That's where the derivative of the G is going to change sign, all right? Then we're going to do the relative max or relative min. So very similar to letter A, but we're doing it with the G function here. So here's all my work for this letter C. All right, here's what I kind of talked myself into the justification here, right? So I wrote down G has extrema where the G prime is either 0 undefined and changes sign. I don't even worry so much about the equal 0 undefined. I'm really focused on where is G prime changing sign. And then right here, we have G prime is equivalent to F. And so where I want to know where G prime changes sign, I really is asking the same question as where does F change sign? And that we can get from our table above. So where does the F change sign? That's why I look up here at the F row and I see negative positive. So X equals 1. And then I see positive, positive, and then positive, negative. So it's at X equals 3. So I jot down for myself that the F changes sign at X equals 1 and X equals 3. And then we're using what we did in letter A. We're using that concept from our 3.3 stuff. We're using our concept from our blue packet here. X equals 1. F is that derivative of G. So this is like my G prime. It changes from negative to positive. So that means the G function went from decreasing to increasing, going down to going up. So X equals 1 is going to be a relative min. So all I'm using is this concept again from your blue packets right here. What makes something a max versus a min? And then this is the justification that we need to write down. I put down relative min at X equals 1 since the G prime, which is equivalent to F, changes from negative to positive. And I got a relative max at X equals 3 since that G prime, which is equal to F, changes from positive to negative. So we started writing like this the last several years. This just means to make it a little more compact, and then that just looks a little bit nicer right there instead of worrying about all that other stuff right there. But G has a relative max where G prime changes from positive to negative and G prime is equal to F. So if you just write it like that, it's all there all in one spot right there. So we'll see a bunch of problems like this. And so we'll keep talking about that and getting better and better with those concepts. And then letter D, I kind of ran out of space on here. So I worked that out on a separate sheet of paper here. But letter D is asking for, to me, this is a little bit simpler than letter C. It wants to know where does G have an inflection point. So G has an inflection point. We know how to find inflection points. That's where the second derivative will change sign. And then what we talked about already, if G is the integral of F, G prime is equal to F, G double prime is equal to F prime. So if I want to know where is G double prime change sign, G double prime is equivalent to F prime. So that's the same exact thing as me saying, where does F prime change sign? All right. So where does F prime change sign? I am then going to look at my F prime row and see where does that change sign. So I see positive, positive, negative right there, change sign at X equals 2, and then it stays negative. So there's only one spot where that F prime changes sign. That's at X equals 2, and I got an inflection point at X equals 2 since the G double prime equals, which is equivalent to F prime, changes sign. So I think if we get in the habit of kind of writing those like that right there, it helps me to talk myself into the answer, and then I just kind of make sure I justify that proper way and using the right notation and stuff there. But if you talk yourself into the answer, at least you know where to look at to get those right answers, and then we'll have that justification down. Watermelon.